Welcome everyone to this video tutorial series about OpenGL. So in this video tutorial series we're going to learn about how to program computer graphics in the OpenGL API. And we're going to use the C++ for the computer programming language here. So to begin with this tutorial you need a basic understanding of C++. If you do not have it, I'd recommend you to go on the web and learn the language first. And the next thing you'll require is an environment setup to program an OpenGL using the glut library. If you do not have your environment set up yet, you can go to my channel. There's a video about how to set up the glut library in code blocks and get started with OpenGL. The video is for Windows. If you're working on any other operating system, I'm sure you'll get help on the web. Now if you already have your environment set up and you know how to compile your glut application, you can get started here. And for the video, I'll leave a link down in the description. You can open the video from there for the environment setup. Now I'll get started with my glut project. You should, in whatever ID you're using, you should know how to compile your glut application. So I'll get started with the glut library and I'll name my project and there is my template code. So the glut library provides you with a template code. You can check it, compile it to check if your OpenGL is working. This is working perfectly. Now the next thing will be we should remove all the template code because we're going to begin from scratch here. So I do not have any code on my screen. Now we'll get started. So the first thing you want to do is include the add the necessary include statements. So first thing will be gl.h, the OpenGL library itself. So this is the header file for the OpenGL API, and the next thing will be glue.h. This already comes with your compiler or with your OpenGL package, so I'm sure this will already be in your system. And the next thing we'll include is the glut.h. This is not by default present in your compiler. You need to do some installation for it, which will be told to you in the video. I just gave you the link of the video, and the link is down in the description. Now if you have your glut library set up, then this will work. And the next thing is that these two header files are already included in the glut library. So you might want to remove this because this will not make any difference. These are already included in the glut library, so they'll be included in your program. Although you might want to put it here because in some versions of glut these are not included and this might give an error. So I'll just keep it here for the explanation purposes. Now the gl.h is an OpenGL API header file, and glue is actually OpenGL utility library which provides several functions which will make your interaction with OpenGL easier. It provides various utility functions, and the glut library is also a utility toolkit which provides first it provides the functions to make your OpenGL a lot easier, and then it provides functions for your to interact with your windowing API, so that the code you write using the for the glut library is independent of the operating system. It deals with the operating system on its own, like creating the windows and stuff. That stuff is done by the glut library. And now once you have included all this, you can start with the main function of the C++, and you might want to keep the command line arguments here because these might be used to initialize your glut. So these are the arguments that have been passed into your program. You might want to keep these, and you'll use this to initialize the glut library. Now we'll get started with the glut library functions. So the functions which are present inside the glut library have a prefix glut, and they'll begin with glut and they'll have various names like these, like glut init. And similarly the functions in the glue library will have a glue prefix like this, glue begin curve, and ones in the OpenGL standard library, the OpenGL API, will have GL prefix. So by looking at the prefix you can identify which library this function belongs to. So we'll use the glut init function to initialize the glut library before we begin to use it. So we initialize it using the arguments that have been passed into the command line, passed into the program from the command line. It takes two arguments, both are of the type pointers. Both of these arguments you need to pass into this function now, because these will be used to initialize the glut library. So both of these are pointers. So first one is not a pointer by default, this one. So you need to use this ampersand sign. And the second one is already a pointer. It is actually an array of strings which contains command line arguments. So you just have to keep this code in your program, in your OpenGl program always. Just don't worry about it, you just keep it as it is. And then after you have initialized the glut library, you need to initialize the display mode that glut will use. Now you might not know much about the display mode right now, but we'll keep learning about it later. But first you need to initialize the display mode using this glut init display mode function. And now the argument it takes is of the type unsigned int. These are actually the constants which are defined in the OpenGl API, in the glut API or the OpenGl API by default. So these will have a glut prefix underscore, and there will be various types of these. The one we're going to use here is RGB to initialize the display mode. So these are the flags, and if you want to specify multiple flags, you can use the OR operator to OR two or more flags together, like glut RGB and glut double. So the display mode will be first RGB mode and double mode. So both of these modes will be used. Although we'll just use glut RGB for now, and we'll save the other flags for later and we'll learn about them. So this is the display mode RGB. Now what RGB means is that RGB is actually the color mode for the API. So red, green and blue. So this will be how the colors will be read by the program. This is how you input the colors. You'll specify the colors to your program. We'll learn more about it in a while, but you just need to keep it here in the initialize display mode function. And after you've done the initialization stuff, you need to create a window on which you use OpenGl. Now I told you that the glut library provides various functions for the interaction with the Windows API, which can by using the glut library you can create the window, etc. The OpenGl does not support creating the window and doing the stuff. You have to use the operating system for that. So that's how glut library makes it easier for you to work with OpenGl. It'll give you it'll make it easier for you to create a simple window and draw your OpenGl stuff in that. So before you create the window, you need to call some initialization functions for the window. So these are glut init window position and init window size. So these two functions. So the first one initializes the position of the window on the screen while it is first displayed, although the window can be translated, but initially it is displayed on a position specified by this function. If you do not specify the position using this function, window is displayed randomly at any point on the screen. So I'll just specify 200, 100. This is in terms of screen coordinates, pixels. So this is where the window will be displayed at this point. And the next argument, next function will specify the width and height of the window. Notice that these two arguments are integers. Similarly, the arguments for this function are also integers. Two arguments and both integers. So this will specify width and height of the window in pixels. So 500 pixels, 500 pixels. This will be the width and height of the window, the size of the window. Now, if you initialize the position and size of the window, you can create the window using glut create window function. This will actually create the window which is to be displayed on the screen. It takes one argument, which is the title of the window. The title is a text displayed on the top of the window. So we'll call it window 1. Now you've created the window, your program will not run yet. What it'll do is, like I'll show you here. The window just displayed and it closed immediately. So that was because the program carried out all its instructions and then it has no option but to quit. Like it created the window, after it created the window, there was no task for it and it terminated. So if you've worked with APIs before, you might be familiar with a term called the program loop or the execution loop. So that is the execution loop is a loop that runs continuously while the program is running, and as soon as the loop breaks, the program terminates. So you need a loop running here until you want to close the program. Until the close instruction is given, the loop will keep running and it will keep the program running. So you will call glut main loop. So once this loop begins, your program has, you'll know that your program has started running. And once this loop terminates, your program will terminate. So after you've done all the stuff, you'll call this loop. Now this loop will take care of all your interactions with your program. So now we've called the loop. It'll still not work because there is a reason for it. Let me show you. So it says that no display callback was registered for window 1, and that's why it terminated. Now what is the display callback? So the Glut library requires callbacks for all types of interactions. So one of the callbacks is a display callback. So display callback is actually a function which is called whenever the window needs to be redrawn or it needs stuff to be displayed on it. So like when the window is first displayed, a display callback has to be called because the window is being drawn. So if you are not familiar with callback functions, the callback functions are just the function that you specify to the API that you specify then after you specify the callback functions, the API can call that function whenever it needs. So that is a callback function. You specify the callback function, you specify the display callback using glut display function, and now it takes one argument, which is a function pointer. So a pointer to a function which returns void and which takes no arguments. So you need to declare a function similar to it. So we'll call it void. Since it is a display callback, we'll call it display and it takes no arguments. And we can now specify the display callback here. So the display callback has been registered as this function. So whenever the window needs to be redrawn, or it needs to be for the first time it needs to be drawn, this function will be called. We need to define the function down here. We'll just leave this function empty for now. So we have specified our display callback, and that means the API has a display callback to call. Now we'll build and run and check if this is working now or not. It again says that display callback hasn't been registered. I made a mistake here. You need to specify the display callback. You need to call the function for the display callback after you've created the window, so that this display callback corresponds to this window. So like you specify the display callback up here, that means it went nowhere. So you first create the window and then you specify the display callback for it. So make sure you do not make this mistake. Now it is going to work. So there we have our window. The background color by default is 1, the dimensions are 500, 500, and the title is window 1, just as we specified. So this is how Glut library enables you to create a window, and we'll begin drawing stuff very soon. But before we begin drawing stuff, we need to do some basic settings for the window. Now you need to know what functions to call inside the display callback. When you first begin to draw on the window, you first need to clear your area, your canvas, or whatever stuff, whatever thing you're drawing on. Like if you're drawing on a whiteboard, you'll first use a duster to clear it. Similarly, before drawing anything on the window, you first need to clear it because you might have some drawings left from the previous frame. Although at the beginning you do not have any drawings from the previous frame, but you might want to inculcate this habit that you always have to clear before you begin to draw. So to clear the screen, so the actual thing on which we are drawing in OpenGL is called a frame buffer. So the frame buffer is actually an area in memory which corresponds to a frame on the screen. So a unit inside a frame buffer, a unit of memory inside a frame buffer, corresponds to a pixel on the screen. So you first need to clear all the pixels of a frame buffer to a default color. You'll want to clear all of it. By default, the frame buffer is cleared when the application first starts up, but for the demonstration purpose, I'll just show you by clearing how you clear the frame buffer right here. So use a GL clear function to clear any types of buffers like frame buffer, depth buffer, or various things, but the one particularly we are going to clear here is the frame buffer. So you need to use a flag to specify what type of buffer you want to clear. So for the frame buffer, the flag is GL color buffer bit. Yeah, this is the flag for the frame buffer. So the color buffer, the buffer which stores the colors for the pixels, that is the frame buffer, will be cleared after the call to this function. But you need to know that the buffer that is being cleared, the frame buffer, the frame buffer that you clear in the memory, is not the stuff that is displayed on the screen. The stuff you're drawing onto is different from the screen. Anything on the screen will not be changed when you make any changes to frame buffer. The frame buffer is first drawn and then displayed after it has been after everything on it has been drawn. So you need to call gl flush function to actually display the frame buffer on the screen. So this is how it works. You clear the frame buffer, then you draw stuff onto it here. After you have finished drawing, you display the frame buffer on the screen. It does not automatically display. So the gl flush function actually displays the frame buffer on the screen. It displays it with whatever stuff it has drawn on it. And similarly, when this display function is called again, it clears, it draws the next frame, and then again displays. This is how basic animation works. We'll learn more about it later. And one additional function call that you need to add here is gl load identity. What this function call does is that it resets all the transformations of the current matrix that you are currently in. It resets the matrix. You will not know much about that right now, but I'll give you a basic hint that since currently we are in the model view matrix, and what this function will does is that it'll reset any rotations, transformations, or any matrix transformations from the previous frame or that has been carried out earlier. So it'll just reset your coordinate system. So that is how it works. So you need to first clear, reset, then draw, and then display. This is how your display callback should function. You can build and run this, but it'll not make any difference yet because we have not actually drawn anything on the screen. We'll begin drawing in the next part, but right now you just need to know the basic initialization stuff that you need to do. And one more thing that I'll tell you to do is the default background color. So we cleared the frame buffer here to the default color. So default color is black, while the frame buffer is cleared to black, and then matrix is reset and the frame buffer is shown on the screen. So that's why by default a screen is black. If you want a different background color, you need to change the clear color for the window. So like when you call this gl clear function, it clears the frame buffer to the default clear color. Now if you change the default clear color to yellow, so all of the pixels of the frame buffer will be cleared to yellow color, and then the default background of the screen will be yellow. So now how to change the clear color? We'll do that in a separate function. We'll define a separate function for initialization purposes here, and we can call it from here. Now to change the clear color, you'll call gl clear color function. Now you can see it takes 4 arguments. You'll not use the fourth argument here. We'll learn about it later. You'll use the first 3 arguments to specify the color. So now how to specify color? So we set the mode of the colors to RGB when we called this in INIT display mode function. So the red, green, blue color mode will be used. So now the first 3 arguments in the clear color function specify the intensity of red, green, and blue colors, which range from 0 to 1. So 0 corresponds to the minimum intensity of that color and 1 corresponds to the maximum intensity. So like you can enter values in between, like 0.5 for the half of the intensity of that colors or other values like that. So the arguments are in the order red, green, blue, and alpha. We'll not use the 4th argument, which is alpha. We just use full intensity of red, full intensity of green, and no intensity of blue. And the last argument we can keep by default 1.0, although this will not affect your program in any way yet. We'll learn more about it later. We'll enable the alpha blending, and then this argument will affect the colors, but for now it will not do anything. So full intensity of red and green, which is equal amounts of red and green, result in yellow color. So the default clear color of our window is now yellow color, and when this clear function is called, the frame buffer will be cleared to yellow color. And when the flush function is called, the frame buffer will actually be displayed on the screen and the screen will be yellow. So let's see if this is working. There we go, we have a yellow background in our window now. So this is how you set the default clear color. And for the rest of the stuff that we're going to learn, we're going to draw, we're going to draw in 3 dimensions, we're going to animate, we're going to do various whole lot of stuff in this video tutorial series. I'll have to ask you to stay tuned and wait for the next part. It'll not take more than a week, so stay tuned, keep watching, and thanks for watching this video.